Section 11.1 is about arithmetic sequences. A sequence is a list of numbers in a particular order. You can have any kind of pattern for those numbers. For example, if I were to list the perfect squares, that's a sequence because there's a particular order to them. These are each number squared, 1 squared, 2 squared, 3 squared, and so on. Each one of the terms, each one of the numbers in that sequence is called a term. So this is the first term, second term, third term, and so forth. Now this is a sequence, but it's not an arithmetic sequence, which is really what we're going to look at in this section. An arithmetic sequence is a sequence in which every number after the first is found by adding a constant to the previous term. And the key here is adding. This sequence that I have up here, you're not adding anything to get from each term to the next term. So here you find an example of an arithmetic sequence. -8, -6, -4, ... If you notice, to get from -8 to -6, you're going to add 2. To get from -6 to -4, you're going to add 2. And to get to every term after that, you're always going to add 2. That makes it an arithmetic sequence. Now this number, this plus 2, is called the common difference. That's the constant that you add to each term to create the next one. Usually we use the letter D to represent that. So we would say that D here is a positive 2. One more thing about notation, we call this first term a sub 1, we call the second term a sub 2, we call the third term a sub 3, and that's how we refer to each term. This is the first term in an arithmetic sequence, the second term, and the third term. In this example, we want to find the next 4 terms of this arithmetic sequence. I'm just going to copy it down again so we can write on it. First, I want to confirm that it is arithmetic by seeing if there's a common difference. To go from 55 to 49, we're going to subtract 6. Or we could think about that as adding a -6. And then to go from 49 to 43, again, we'll add a -6 or we'll subtract 6. So it appears as if my D, my common difference, is -6. So all you have to do now is start from 43 and subtract 6 4 times to find the next 4 terms. 37, 31, 25, and 19. Here we're given the formula for any arithmetic sequence to find the nth term, whatever n is, first, second, third, fourth, fifth. This is the formula that you're going to use. Now the formula is made up of different parts, and I'm going to show you what those are right now. This a sub n stands for the nth term. So whatever n is, whatever the number of the term is, you use a sub whatever that number is. A sub 1, that's the first term. Because it has a sub 1, that's whatever the first term is you put in there. N is the number of the term, and the D is the common difference. So we have an example here where we're going to use this formula to help us solve. It says, look at the information in the table, assume it's another arithmetic sequence, how much would it cost to rent the crane for 12 months? Here we're given a set of values that go up to 4 months and how much that costs, and we want to figure out what it would cost for 12 months. So we want to find the 12th term of the sequence. And the first thing we want to do is confirm that this is really an arithmetic sequence. To go from 75,000 to 90,000, you're going to add 15,000. And to go from 90 to 105, you're going to add 15,000. So it appears as if this is arithmetic, so we can use this formula to solve it. Now we want to find what it costs after 12 months, so we want to find the 12th term of the sequence, so a sub 12. A sub 1 is the first term of the sequence, you find that right there, 75,000. Plus n minus 1, now n is the number of the term we're looking for. We're looking for the 12th term. So 12 minus 1. And then the common difference, the D, is 15,000. To get from each term to the next one, you're going to add 15,000. So we can use all of this to find out what a sub 12 is, or the 12th term in the sequence. If you do 11 times 15,000 plus 75,000, you plug that into a calculator, you get 240,000, which is how much it would cost to rent this crane for 12 months. In this one, we're asked to find the nth term, which means we want to find an equation for any number term, which means we're not going to actually know what n is, and we're going to have to make this equation style. So let's confirm that this sequence is arithmetic. To go from 8 to 17, it appears as if I'm going to add 9. Does that continue? Add 9 and add 9. So this is an arithmetic sequence, so we can use our formula. Now because we're looking for the nth term, we don't know what a sub n is. We do know what a sub 1 is, that's the first term. Again, we don't know n because we're looking for the nth term, and the common difference is 9. So now I'm going to use algebra to simplify this. Distributing, we'll get 9n minus 9. And then you see like terms here, 8 minus 9 is negative 1. So I'm going to write it as 9n minus 1. So this is the equation for the nth term. This equation acts like a function. If I plug a 1 in for n, this tells me what my first term of my sequence is. If I plug a 2 in for n, this tells me what my second term of my sequence is. And if I plug 100 in for n, this tells me what the 100th term of the sequence is. So this is the equation for the nth term. Here we're going to look at something called arithmetic means, and those are the terms that are between any two non-successive terms in an arithmetic sequence. Non-successive means they're not right next to each other. So down here in this example, you'll see that if I want 3 arithmetic means between 30 and 74, that means I want to know the 3 values of the sequence that come between 30 and 74. Those are called the means. So in this example, I want to find 4 arithmetic means between 16 and 91. The problem is I don't know what the common difference is. So the first thing I want to do is find the d. That's our first order of business. Well, let's start with our formula because that's really the only thing we have to work with. If I could plug in the other values and solve for d, I'd be able to write out my sequence and then find what the 4 arithmetic means are. Well, if I want to find 4 values between 16 and 91, that means this one would have to be my first term, a sub 1, and this one would have to be my 6th term because there's 4 between. So I'm going to say that a sub 6th, because I know what the 6th term is, I know it's 91, so a sub 6 equals a sub 1, which is 16, plus my n, which is 6, times d. Now further plugging this in, I know that a sub 6 is 91, so 16 equals 5, plus 5d, and now I'm just going to solve for the d. So we'll find out that d equals 15. So now if I know that d is 15, I know I'm going to start at 16 and I'm going to get to 91. If I add 15 to this number, I get 31. If I add 15 to that, I get 46. 15 to that is 61, and then 76. Here's the 91 that I knew from before. So my 4 arithmetic means between those two numbers are right there.